Hello all, welcome to the Counting Well exam prep live session. We know that exams are around the corner and it's time to push yourself to study hard because no one else is going to do it for you. So just wish to score good and work for it. And we are here to help you revise the concepts before it's too late. For this, stay tuned to the session and build up the confidence to face your exams. In this session, I will take you through the chapter Whole Numbers and Integers from class 6. Let us see some basics from the chapter Whole Numbers. Now, to distinguish between natural numbers and whole numbers, we should know what are natural numbers and what are whole numbers. So, natural numbers start from 1 and go on, whereas if we add a number 0 to it, we'll get whole numbers. So, we have natural numbers 1, 2, 3 and whole numbers starting from 0. So we have 0, 1, 2 and so on. Let us see what is a predecessor and successor. Predecessor is nothing but number minus 1. So predecessor of 125 is nothing but 1 less than 125, which is 124. Successor is a number with 1 added to that number. So successor of 307 is 308. Let us see some operations on number line. So we have addition, subtraction, multiplication. Let us see how to add numbers using number line, subtract and multiply. To add two numbers on number line, we have to move forward. So first of all, you have to mark 2 on the number line as we are adding 2 and 7. Then we move 7 steps forward. So we get the number 9. Similarly, for subtraction, to subtract, we move backward. So first we mark the number 11 because we are subtracting 6 from 11. We move 6 steps backward. So we have number 5. Let us see for multiplication. For multiplication, we have to move in units to the right. So you can see here there are 3 units and 4 steps to the right. And each step should have 3 units. So moving 4 steps with 3 divisions in each step, we get the number 12. So this is how we add, subtract or multiply numbers using number line. Let us see some properties of whole numbers. Let us see properties of whole numbers for addition, subtraction, multiplication and division. For any whole number A, B and C, if we add two whole numbers, then the resulting sum is also a whole number. Whereas the order in which the numbers are added in case of whole numbers doesn't matter in their sum. So A plus B is same as B plus A. For associative property, we are dealing with 3 whole numbers A, B, C. So here A plus B added to the number C is same as A added to B plus C. Let us say what is additive identity of any number. It is a number which when added to that given number will give you the same number. So here you can see when 0 is added to the number A or any whole number, we'll get the same whole number A. Let us see for subtraction. For any whole number, for any two whole numbers, if we subtract two whole numbers, we cannot get the subtraction always as a whole number. For example, 0 minus 1. It will be minus 1 and minus 1 is not a whole number. So subtraction is not holding for whole number. Let us see the commutative property. It says that no matter how the numbers are multiplied. So here you can see the subtraction a minus b is not same as subtraction b minus a. Let us see the associative property. A minus b minus c is not equal to a minus b minus c. So here the order in which the numbers are subtracted is important. That means 3 minus 2 will not be same as 2 minus 3. Now let us see for closure property of multiplication. Multiplication of two whole numbers is again a whole number, and a into b will be same as b into a. That means 2 into 3 will be same as 3 into 2. Associative property, we have the order of numbers which occurs in the product is not important. So you can multiply ab and then multiply it by c, or you can do b and c multiplication first and then take the multiplication with a. The resulting answer will be same. Property of 0, let us see. Multiplying 0 with any whole number will give you the number 0. This is what the property of 0. Let us say distributive property. It says that multiplication distributes over addition. So this is called distributive property of multiplication over addition and subtraction. So a into b plus c will be distributed as a into b plus a into c, whereas a into b minus c will be distributed as a into b minus a into c. Multiplicative identity of whole number is nothing but the number which when multiplied to the whole number will give you the same whole number. So multiplicative identity of any whole number is 1, whereas additive identity of any whole number is 0. For division, the closure property is not hold. For commutative also, it is not true that a divided by b will be equal to b divided by a. Hence, associative property also does not hold good. Let us see some basics from the chapter integers. Integers are nothing but positive numbers, negative numbers, and 0. So it is set of whole numbers along with the negative numbers. So here you can see natural numbers are counting numbers, and if we add one number or element 0 to that set, we'll get whole numbers. And when we have negative numbers as well, in addition to whole numbers, we get the set of integers. So integers on number line are represented like this. We have 0, which is neither positive nor negative, and to the right of 0 we have positive integers, to the left of 0 we have negative integers. Again, successor of any integer is one step to the right of the given integer. So successor of 2 will be one step right to it, which is 3. So successor of minus 2 will be one step right to it, so it will be minus 1, and so on. The predecessor of an integer is one step to the left of the given integer. So predecessor of minus 2 is minus 3. Predecessor of 2 will be 1, of 1 will be 0, and so on. So you have to locate the predecessor to left of the given number. Now let us see how to compare integers using number line. So it is as simple as this statement. So we have here one inequality. The integer to the left is less than the integer to the right. So minus 1 will be less than 1, minus 3 will be less than 0, 2 will be less than 3. That is 1. If it is left to the 0, you can see 1 is left to 4. So 1 is less than 4. Minus 7 is left of minus 1. So minus 7 is less than minus 1. If you want to compare without using number line, then for positive integers we have when the digits gets bigger, then the value becomes bigger. For example, 138. The number of digits are 3. In case of 47, the number of digits are 2. So here 138 has greater value than 47. So we have 138 greater than 47. Whereas for negative integers, as digits gets bigger, the value becomes smaller. So here you can see there are 3 digits and this number is negative. There is 1 digit in this number. So the value is bigger. So minus 247 will be less than minus 2. Also, positive integers are always greater than negative integers, and 0 is always greater than the negative numbers, whereas the numbers right to the 0 are always greater than 0. So numbers to the left of 0 are always less than 0, and the numbers to the right of 0 are always greater than 0 if we are comparing with 0. Let us see some operations on integers. So we have addition operation using number line. So whenever you are adding two integers as shown, one is negative and one is positive. First of all, we have to mark an integer on the number line. So how we are marking? We are marking minus 8 and then we are moving forward with 3 steps because we are adding 3. So we'll get minus 5. That's why minus 8 plus 3 is minus 5. So first step is what? To locate the first number. So here we are locating minus 8 is 8 units towards the left of 0. So here we are marking minus 8 and then we are moving forward by 3 steps. So we have minus 5. If we are not using number line, then you have to remember this rule: same sign, add and retain the same sign. Different signs, subtract and retain the sign of greater number. So if the two integers have same sign, for example, here both the signs are negative. So negative, negative, you have to add 14 and 56. And then you have to write the value and then you have to retain the same sign. So since both the integers have negative sign, you have to write minus here. If they have different signs, means one is positive, one is negative, then you have to do subtraction. So here you have to subtract 25 minus 9. You have to write the value and then you have to retain the sign of greater number. So which number has greater value here? 25 or 9? It is 25. So we have to write it as 16, not minus 16. Let us see for subtraction. We know for subtraction we move backwards. First of all, we have to locate minus 4, which is 4 units to the left of 0. So here we have minus 4. Then we are subtracting minus 8. Correct? So we are moving backward. So when we are moving, so here you can see we have the number 4. We have to move 8 units. Let us see without using number line how we can do. Subtraction of integers is same as adding the additive inverse. Okay, so if you want to subtract minus 7 from 18, you have to write the additive inverse, which is 7. So it is 18 plus 7, so we have 25. Note that here we are moving backward or forward. You have to note this carefully. Here we have negative or minus 8, so we are moving in this direction. Okay. Let us see some tips and tricks for exams. Whenever we are adding two whole numbers, then this trick is very helpful to simplify the process by making all the numbers a multiple of 10. So here you can see 726. If you want to make it multiple of 10, we can write it as 730. Here we have 433. Multiple of 10, we can write it as 440. So adding 730 and 440, we get 1170. So remember, first you are rounding up the numbers. Rounding up means we are taking a number multiple of 10 and it has to be rounded up. So 26 has to be 30, not 20. So here we are rounding up. Then what we are doing? we have to determine how much we have added while rounding up. So here you can see, to convert 726 as multiple of 10, we are added 4 to this number. For second number, we have added 7. So we are adding this number. So we have 11. And this 11 we are subtracting from this sum, 1170. So here we get 1159, and this is nothing but the sum of the given two whole numbers. Let us see trick for subtracting numbers. So whenever you are subtracting a number from a number, like numbers having multiples of 10, 100,000 and so on, we are using this trick. The trick is we have to subtract 1 from each of these two numbers, and then we have to subtract the numbers obtained by subtracting 1 from each of the numbers. And the subtraction will be same as the subtraction of the original numbers. Note that we are using this trick only for such numbers which are multiples of 10, 100,000 and so on. And we are using this trick in order to avoid the procedure when we are borrowing the numbers. Otherwise, you have to do 0 minus 7. So you need to borrow numbers from the next digit. If we do subtraction like -1 from each of these numbers, then we'll get 9 minus 6, which is 3. 9 minus 6 is 3. 9 minus 5 is 4. So the subtraction of the digits gets easier in this case. Let us see how to multiply large numbers if one of them is even. In such case, you have to divide the first number in half and double the second number. So whichever number is even, divide it by 2 and double the second number. So here you can see 18 into 187. Here which one is even number? Yes, 18. So you have to divide it by 2, you will get 9. Then you have to double 187, which is 374. Now you have to multiply 9 and 374 instead of 18 and 187. Note that here you are multiplying a 2-digit number with a 3-digit number, but here you are multiplying 1 digit with a 3-digit number. So here the multiplication becomes easier. So multiplying, we get 3366, and which is the product of the original numbers given. And whenever you are multiplying by numbers 999 or 999, it is always better to make it as 10 minus 1 in case of 9 and 100 minus 1 in case of 99 and 1000 minus 1 in case of 999. Then you can apply the distributive property of multiplication over subtraction. So here you can see the product of 87 and 99 can be made easier by writing 99 as 100 minus 1. So this will be 87 into 100, 8700 minus 87 into 1, 87. So we have 8613. Next we have 124 into 999. So we are writing 999 as 1000 minus 1. Then we are using the distributive property of multiplication over subtraction. So we have 1,24,000 minus 124, which is 1,23,876. Let us see when we are dividing any number by 8. What we are doing, we are dividing that number 3 times by 2, correct? So once you half that given number and take half of the number obtained in this step again, and again divide it by 2, you will get the resulting final answer as 935 in case of 7480. Similarly, if you want to divide 14,852 by 8, then thrice you have to half it. So here we have 7,426. Taking half of this number, we have 3,713. Taking half of this number, we have 1,856.5. So this is the trick whenever you are dividing any number by 8. Let us see the rules for rounding numbers. So the rule is very simple. If the digit is 0, 1, 2, 3 or 4, which is numbers less than 5, we do not have to change the rounding digit, and all the digits on the right hand side of the requested rounding digit will become 0. And if the digits are any of these, we have to round down the number, otherwise we have to round up. For example, if you have to round off this number 7842 to the nearest tens, so which is the tens place? Yes, this one. Now we have to look which digit ones place. Whenever you are rounding up to nearest tens, you have to observe the ones place. You have to apply this rule. If the digit is 0, 1, 2, 3 or 4, we have not to change the rounding digit. So here it is 2. So you have to change it to 40. So we are not changing the digit on the tens place. It is 4 only. And it is rounded down because 42 has changed to 40 now. And if the digit is 5, 6, 7, 8 or 9, the rounding digit rounds up by one number. So rounding up will become when the digit is greater than or equal to 5. So we have 5, 6, 7, 8 or 9. So on the right hand side, the requested rounding digit will become 0. And yes, if it is 5 or greater than 5, we are rounding up, not rounding down. So if you want to round off 35,489 to nearest 100, you have to observe which place? 100 place. And then you have to observe the tens place to apply this rule. We can see 8 is greater than 5. That's why we are rounding up. So we have 35,500. And we are changing this digit. We are changing 4 to 5. Now, whenever you are writing Roman numerals, you have to remember this rule. When smaller numerals are on the left of larger one, you have to subtract them. Whereas when it is written on the right side of larger ones, you have to add them. And you can never use more than 3 of the same symbols. So when we have 4, it is 1 before 5. That's why we are placing this I letter to the left of the letter V. So ninth is written as 1 before 10 because we are subtracting 10 minus 1. Similarly, here we have 50 minus 10. Here we have 100 minus 10. Here we have 500 minus 100. Here we have 1000 minus 100. Note that M stands for 1000. C stands for 100. D stands for 500. C stands for 100. C stands for 100. X stands for 10. And here the maximum number of times we can repeat the symbol is 3. So we cannot write 4 as 4 I's. Here we can see I letters are placed to the right of the letter V. That's why we are adding 5 plus 1 plus 1 plus 1. That is 8. Let us see how to subtract numbers from 1000. Here is a basic rule whenever you are subtracting any number or any larger number from 1000. The trick is subtract every number except the last from 9 and subtract the final number from 10. For example, when you're subtracting 556 from 1000, what we are going to do? We are going to subtract 6 from 10, which will be 4. Subtracting 5 from 9, which will be 4. Subtracting 5 from 9, which will be 4. So we have 444 as the final answer. Similarly, whenever you're subtracting 487 from 1000, subtract 7 from 10. So we have 3. Subtract 8 from 9, we have 1. Then 4 from 9, so we have 5. Whenever you're multiplying 5 to any number, here is a quick way to do so. So here you're multiplying 5 and 26. So you have to have the number being multiplied by 5. So this will make 26 as 13. Then you have to add 0 to the number to find the final answer. In this case, the answer is 130. So what we have done? We have done the half of the number being multiplied by 5. So half of 26 is 13. We have to add 0 to right side. So we have 130. Now when we are multiplying an odd number by 5, the formula is a bit different. So for instance, if you want to multiply 5 to 13, as 13 is an odd number, you have to subtract 1 from the number which is being multiplied by 5. For instance, the odd number here is 13. So if we subtract 1 from 13, we have 12. Now you have to halve the number 12, which is 6, and make 5 as the last digit of the number. So we have 65. For example, if you want to multiply 5 and 17, what is 1 less than 17? It is 16. What is half of 16? It is 8. What is last digit? We have to add here, we have to add 85. So here we have 5 into 17 as 85. Let us see how to multiply numbers ending in 0. So whenever you're multiplying numbers ending in 0, you have to involve multiplying the other numbers, then add zeros at the end. So here you have to do 2 into 4. Then you have to add 4 zeros, because here we have total 4 zeros. So we have 4 twos are 8. So 8 followed by 4 zeros. So this is our final answer. While dealing with the chapter whole number, you have to remember this table. That means addition of two whole numbers is always a whole number. While in case of subtraction, it doesn't belong to the set of whole numbers. It goes with multiplication, but it doesn't goes well with division. As we have discussed, commutative property for addition of whole numbers is true, whereas for subtraction and division, it is not true. It is true for multiplication also. Associative property for addition holds good, whereas for multiplication also it holds good, but it doesn't holds good for subtraction and division. Distributive property of multiplication over addition, we have a into b plus c equals to a into b plus a into c, whereas a into b minus c will be a into b minus a into c. Now, when we are using positive integers and when we are using negative integers, for that, let us see this chart. We have to remember this context. Whenever you are finding or whenever you're dealing with temperatures above 0, we are using positive integers, or the numbers used for above sea level reading, or whenever there is a situation of earning money or situation of profit, whenever you are dealing with the floors above the ground level, or there are keywords like increase, up, deposit, gain, calories eaten, we are using positive integers. Whereas in case of temperatures below 0, below sea level, owing money, loss, or basement or car park level, and the keywords used are decrease, down, withdrawal, loss, calories burned, we are using negative integers. In short, whenever there is increase in a quantity, we use positive integers. Wherever it is decrease in quantity, we are using negative integer. Now, we should not get confused between the successor and predecessor of integers. Remember that successor is one step to the right of the given integer when we are using number line, whereas predecessor is one step left to the given integer on the number line. Also, You can find successor by adding 1 to the given integer and predecessor by subtracting 1 from the given integer. For example, successor of minus 84 is obtained by adding 1, which is minus 83. Predecessor of minus 35 is obtained by subtracting 1 from minus 35. So we have minus 36. Whenever we are comparing negative integers, note that as the digits gets bigger, the value becomes smaller. So here you can see 36 and 98 have negative signs. So the digits getting bigger were here. So 98 is greater from 36, but the value is smaller because minus 36 is to the left of 0, but it is to the right of minus 98 on the number line. While addition of two negative or two positive integers means integers having same sign, we have to add them and you have to retain the same sign. So in case of two positive integers, add the numbers and retain positive sign. In case of two negative integers, add the numbers and retain the same sign, which is negative sign. Whereas if the integers have two different signs like positive and negative or negative and positive, we have to subtract the numbers and then we have to keep the sign of greater number. So here we have to subtract 21 from 43, which will be 22, and check which of these numbers have greater value. So here 43 has greater value. So we take the sign of 43, which is minus sign. So the resulting answer is minus 22. Remember that subtraction of two integers is same as addition with the additive inverse. So if there is a chance of you getting confused while you're subtracting two integers, you can simply do or follow this step. So 12 minus 23 is same as 12 plus minus 23. Note that minus 23 is additive inverse of 23. So we are adding the additive inverse to the integer. So we get here minus 11. Let us see what are some common mistakes a student can do when the student is dealing with these two chapters. You should group friendly numbers. For example, when you have to apply associative property, you should take care when you are grouping the numbers. So this should be ideally grouped as 67 plus 13 plus 245, as 67 plus 13 will give you 70 and it is easy to add 70 to 245. So 67 and 13 are friendly numbers as their sum is multiple of 10, 100, 1000, etc. So you have to group the friendly numbers. Friendly numbers are nothing but numbers whose sum is a multiple of 10, 100, etc. Now distributive property of addition over multiplication. For any three whole numbers, the distributive property can be done as A into B. Then we have to take addition sign, then A into C. This is the correct way. Here what we are distributing the multiplication sign over addition. So distribute multiplication over addition. Whereas the second method shown is not the correct way. Let us see properties of 0. When it is added to any number, we get the resulting number itself. But when it is multiplied by any number, we get the resulting number as always 0. Even for 0. So 0 multiplied with 0 is 0. And 0 added to 0 as well will give you 0. The successor of a whole number is a whole number which is one step to the right of the whole number. So you have to remember that the successor of a whole number should also be a whole number. So successor of 3 is 2 or 4. It is 3. If we move one step to the right of 3, we get the successor of 3. So successor of 3 is nothing but 4, which is one step right to the number 3. Well, predecessor of a whole number should also be a whole number and one step to the left of the whole number. So the predecessor of 2 is 1 or 3. One step to the left of 2 is 1. So we have predecessor of 2. So do we have predecessor of 0? No, we do not have predecessor of 0 for whole numbers because to the left of 0 we do not have any whole number. Let us see successor of an integer. We know it is one step right of the integer. So for successor of -3, moving one step to the right, we have -2. So -2 is a successor of -3 and not -4. Predecessor of an integer. So predecessor of integer -1 is -2 or 0. Whenever you're finding predecessor of -2, you're moving one step left. Okay. So one step left of -1 is -2. So predecessor of -1 is -2. Whenever you are comparing negative integers, -98 and -13, the number with bigger digit is always smaller than the number with smaller digit. For example, here you can see 98 and 13. Which one is bigger digit? 98, but its value is smaller. So -98 will be less than -13. Yes, so the first way is correct. First comparison. In case of addition of integers, remember we have to follow the below steps. If integers are of the same sign, you have to add and keep the same sign. Whereas if the integers are of different signs, you have to subtract and keep the sign of greater number. So for example, here you can see adding -14 and -21, both have the same sign. So we are adding 14 and 21, it is 35. But the sign of both the numbers is minus, so we have to retain this number with minus sign. So -14 plus -21 is -35, and other three ways are not correct. Let us see, when we are adding two integers having different signs, we have to subtract the numbers. So we are subtracting 14 from 21, which is 7. Which one is greater number or number having greater value, 14 or 21? It is 14. Sign of 14 is minus. So we have -14 plus 21 equal to 7. If you are listening me carefully, then which one is greater number, 21 or 14? It is 21. And the sign of 21 is positive. So here we are writing +7. Let us see subtraction of integers. Subtraction of two integers is same as the addition with the additive inverse, as I told you. So if you are subtracting 19 from 15, then note the additive inverse of 19 is -19. So 15 minus 19 is same as 15 plus -19, which is -4. That's why 15 minus 19 is -4. Now let us subtract -25 from 21. So additive inverse of -25 is 25. So 21 minus 25, or 21 minus of -25 is 21 plus 25, which is 46. So we have 21 minus 25 equal to 46. Let us see one more example, subtracting minus 25 from minus 21. So additive inverse of minus 25 is 25. So subtracting minus 25 from minus 21 is same as adding 25 to minus 21, which is equal to 4. That's why minus 21 minus 25 is 4. Let us see some exam tips for these two chapters. You have to practice a variety of questions from NCERT textbooks, exemplar other textbooks, and from previous year question papers. Then you have to note down all the definitions and properties separately so that you can glance at it before you are going to attend the exam. You have to avoid calculation mistakes, and you have to study the properties of whole numbers carefully and also focus on distributive property. You should not forget about the sign of an integer whenever you are adding or subtracting them. Also, while solving word problems, you have to write what is given in the question, what you have to find. This helps in identifying the right strategy or formula. Also, you have to read the given question carefully and understand it. You have to check if you have answered all the questions and parts of the questions. I hope this session was helpful, and if you want to quickly revise the concepts, practice some extra sums, and also take a quick test, Counting Well Exam Prep Kit is here. It lets you quickly glance through the major concepts of your chapter. You can also glance through the solved examples, practice questions, and chapter assessments. You will also understand the tips and tricks, common errors that you make, etc. Over 75,000 students trust Counting Well for their maths learning, and without the exam prep kit, they can learn every day on the app by diving deep into every chapter. You can download the app from the App Store or Play Store. Also, stay connected to our channel Counting Well and learn more tricks and tips and ways to avoid common mistakes. We will be revising chapters from next class in our next live session on Monday at 6:30 p.m. Well, see you in the next session. Until then, keep learning, keep